Hi, hi, my name is Hamza Sahi, and this is my Assignment 5 Interpreter project. Before I start the demo, I want to claim my grade. I'm claiming full points because I have implemented all the required features from Assignment 3 and Assignment 4, and I've also added some extra features like a while loop and show output for K-Affinity. So in this video, I'll be showing the interpreter running. I'll talk about how I made my language work. I'll explain the grammar. I'll show you the grammar that I designed, and then I'll walk you through each test case, including the error case. Let me begin by quickly explaining the idea behind my interpreter. For this assignment, we basically had to combine the expression evaluator from assignment 3 and the function and lambda interpreter from assignment 4 and turn it into a complete mini language. My interpreter handles two languages at the same time. One language is scheme style, which we have already used before for lambdas and arithmetic. The second language is my own language that I designed, which is called Kfinity. Kfinity looks a bit like C or JavaScript because it uses let, semicolons, curly braces, and so on. Because these languages run on top of the same interpreter, so deep down the code translates everything into expressions that my evaluator can understand. It supports integers, booleans, math, conditionals, functions, and variable binding. And for Kaffinity, I also implemented while loops, which is a bonus feature. So in this report, I included the grammar, the mapping, and the environment. Now I'll show you the VS Code. Here you can see my files lang.hs, readme.md, parsing.hs, and branch A and then branch B. And this is basically my code. And, and this is the readme file, this is the parsing file, this is the branch A, and then this is the branch B. Now I'll be switching to my terminal. I've already loaded the GHCI for my test. So this is the test number. Let me show you the test number one. The test number one is a basic simple arithmetic and scheme. And like this returns num v5. This shows that arithmetic evaluation from my assignment works perfectly fine. And the second test is the lambda with identity. And this is a simple lambda that just returns whatever you pass in. And the result is num v10. This proves that uh, lambda evaluation and argument substitution work uh, completely fine. And the third test is the lambda plus arithmetic. This is also in scheme. I have a lambda that adds 1 to the argument, and the output is num v6. And the fourth test is an if statement test, because in this test, because 3 is less than 5, the interpreter chooses the 100 branch, and the answer is num v 100. And this confirms that conditionals and Boolean expressions are working. And the test number 5 is now here's where we switch to my language Kaffinity, and the code is let a is equal to 10, b is equal to a into 2, and show b. The output environment shows that a is 10 and b is 20, and the show output list is num v20. This demonstrates variable binding, rebinding, math, and bonus show feature. And the test number 6 is basically K-affinity while loop. This demonstrates a while loop, and this loop prints 3 to 1 and then exits and reaches 0. You can see the output here, which is num v3, num v2, and num v1. This is a bonus feature because while loops were not required, but I added them. And the last test is an error case, and this is the code is let x is equal to y plus 1. And since y is not defined, the interpreter raises exception unbound identifier y. This shows that my interpreter correctly detects invalid variable usage. So overall, I demonstrated all the required features: expression evaluation, arithmetic, Boolean logic, conditionals, function, and lambda evaluation, variable binding, and error handling. And on top of that, I added two bonus features: in Kfinity, while loops show output, which were not required, but I completed them to make the language feel more real. And this completes my demonstration for my assignment. Thank you for watching.